Have you wondered how the Earth stays in orbit? Believe it or not, the Earth stays in orbit because of the same concept that a blood centrifuge uses. Have you ever been in a car that takes a sharp turn and felt like you were being pushed outward? Or spun a bucket of water in a circle and noticed the water sticks to the bottom instead of falling out? That feeling, and that effect, is what we call centrifugal force. Here's what happens in a blood centrifuge tube loaded into rotor. Blood is placed in a small tube and put into the rotating holder, called a rotor. Spinning begins. The rotor spins very fast, often thousands of times per minute. Centrifugal effect separates components. As the tube spins, heavier components, like red blood cells, are forced outward more strongly. Lighter components, like plasma, stay closer to the center. This outward push felt inside the rotating frame is what many explanations call centrifugal force. Layers form based on weight. After the spin, the heaviest part, red blood cells, is at the bottom of the tube. Above that is a thin layer of white blood cells and platelets. The lightest, plasma, stays at the top. Pushpin why it matters. This separation is useful because plasma can be tested for sugar, hormones, etc. Have you ever wondered why Earth doesn't just fly off into space? After all, it's moving around the sun at about 30 kilometers per second. That's fast. So why don't we drift away? Here's the key. Earth is moving sideways, very fast. That motion creates an outward tendency, what we describe as centrifugal force in a rotating frame. If that were the only thing happening, Earth would escape into space. But it doesn't, because the sun is pulling on it. Gravity pulls Earth inward, so now we have two effects, an outward tendency, and an inward pull. And orbit happens when those two are balanced. So this is why we are in orbit, not in space, nor pulled in the sun.